Mark your calendar. April 13th, 2029. It's a Friday. Friday the 13th, to be exact. And on that night, if you look up at the right moment, you will see something humanity has never witnessed before. Not through a telescope, not on a live stream, with your naked eye. A point of light, bright as a star, streaking across the blackness, moving fast, too fast, silent, and massive enough to level a country. That light is Apophis, the Egyptian god of chaos, an asteroid the size of the Empire State Building. And on April 13th, 2029, it will pass closer to Earth than our own weather satellites. Let that sink in. Closer than the satellites that beam your GPS, your weather forecasts, your emergency broadcasts. An object weighing roughly 65 million tons will skim past us at a distance of just 31,000 kilometers. That's less than 1/10 the distance to the moon, so close that Earth's gravity will bend its trajectory, so close that it will be visible to over 2 billion people, so close that had its timing been off by mere hours, had the cosmic dice rolled differently, we wouldn't be making documentaries about it. We'd be making evacuation plans. But here's the part that should make your stomach drop. 2029 isn't the end of the story. It might just be the beginning, because when Apophis whips past us on that Friday night, it will be flying through a gravitational minefield. A narrow corridor in space where, if the asteroid hits the exact wrong coordinates, Earth's gravity will slingshot it into a new orbit. An orbit that brings it back. Not in a century, not in a millennium. In 2036. And if it comes back in 2036, scientists have a word for what happens next. They call it an impact winter. So no, this isn't science fiction. This isn't a conspiracy theory. This is orbital mechanics. And the clock is already ticking. The story doesn't start in 2029. It starts on a warm June night in 2004 at the Kitt Peak National Observatory in Arizona. Two astronomers, Roy Tucker, David Tholen, and Fabrizio Bernardi, were running a routine survey, scanning the sky, looking for near-Earth objects, boring, methodical work, the kind of work that almost never makes headlines. Until their telescope caught a blip, a dot, a faint smudge of light moving against the background stars. At first it was just another rock. There are millions of them. But then they ran the numbers, and the numbers came back wrong, very wrong. This thing was big, roughly 340 meters across, wide enough to swallow a football stadium, and it was coming our way, not in centuries, in decades. The initial orbital calculations suggested something chilling. Apophis had a 2.7% chance of striking Earth in 2029. That's roughly 1 in 37. In asteroid terms, that's not a possibility. That's a coin flip with extinction on the line. NASA didn't panic publicly. But privately, the emails flew. The simulations ran. The Torino scale, a metric used to categorize asteroid impact hazards, lit up like a Christmas tree. Apophis briefly hit level 4, the highest threat level ever assigned to an object in modern history. Level 4 means a close encounter meriting attention by astronomers. Current calculations give a 1% or greater chance of collision capable of regional devastation. Regional devastation. That's not a crater in the desert. That's not a cool explosion for a movie. That's an energy release equivalent to over 1,000 megatons of TNT. For comparison, the Hiroshima bomb was 15 kilotons. Apophis, if it hits, would pack the punch of 65,000 Hiroshimas. It wouldn't just destroy a city, it would erase a region the size of France. The shockwave would flatten forests, the dust would choke the stratosphere, crops would fail, temperatures would drop. And in 2004, we thought there was a 1 in 37 chance this would happen in 25 years. Let's talk about why 2029 matters so much. Because this is where people get confused. They hear close approach, they think cool astronomy event, they picture a pretty light in the sky. But 2029 is a gravitational keyhole, and keyholes are where asteroids go from being a spectacle to being a sentence. Imagine you're throwing a dart at a dartboard, but the dartboard is moving, and the dart is traveling 30 kilometers per second. And instead of a board, the target is an invisible window in space roughly 600 meters wide. If the dart passes through that window, if Apophis passes through that exact gravitational keyhole during its 2029 approach, Earth's gravity will grab it. Not enough to pull it down, just enough to bend its path, to redirect it, to place it on a trajectory that intersects with Earth 7 years later in 2036. That's the keyhole, a cosmic trapdoor. Now, here's what changed. After 2004, astronomers spent years refining Apophis's orbit. Better radar, better telescopes, better math. By 2013, NASA had ruled out the 2029 impact. By 2021, after a close radar pass, they ruled out the 2036 impact too. The official line? Apophis poses no risk for at least 100 years. But here's the viral truth that keeps planetary defense scientists up at night. Ruling out an impact is not the same as controlling the object. We've only tracked Apophis for 20 years. Its orbital period around the Sun is 324 days. That means in 2 decades, we've seen it complete roughly 22 orbits, 22 laps around the Sun. That's not enough to know everything. That's enough to know the broad strokes. The fine print, still being written, and the fine print is where the devil lives. You might think, NASA says we're safe. Why are we still talking about this? Because space doesn't care what NASA says. Space cares about physics, and physics has a habit of hiding surprises in the margins. Let's start with the Yarkovsky effect. This is one of those terms that sounds made up, but it's actually one of the most insidious forces in asteroid dynamics. Here's how it works. Apophis is spinning. As it tumbles through space, one side faces the Sun, heats up, and radiates infrared energy. That radiation acts like a tiny rocket thruster, a whisper of force, barely measurable. But over 25 years? Over 25 years, that whisper becomes a scream. The Yarkovsky effect can shift an asteroid's position by thousands of kilometers. We think we know Apophis's trajectory, but if we don't know its exact spin axis, its exact surface composition, its exact thermal properties, we don't know the Yarkovsky drift. We're navigating a bullet while guessing the wind. And then there's the composition problem. We know Apophis is an S-type asteroid. Stony. Probably a rubble pile. But is it one solid rock? Or is it a loose collection of boulders held together by gravity? Because if it's a rubble pile, the 2029 close approach changes everything. Earth's gravity could stress it. Tidal forces could reshape it. Fragments could break off. We could go from tracking one asteroid to tracking a shotgun blast of debris. In 2029, Apophis will pass so close that tidal forces will physically act on it. If it's fragile, it might fracture. If it fractures, the pieces scatter. And scattered pieces are harder to track, harder to predict, and infinitely harder to stop. But there's something else. Something NASA doesn't put in press releases. The 2029 approach will be the closest any asteroid this size has come to Earth in recorded history. We have no precedent for this. We have no data on what happens when a 65 million ton object passes within the orbit of our geostationary satellites. The math says it misses. But the math also said the Titanic was unsinkable. Let's play it out. Let's walk through that Friday the 13th in real time. Because this is where the documentary gets personal. This is where you realize this isn't happening to astronauts. This is happening to you. It's evening. Local time depends on where you are, but across Europe, Africa, and Asia, the sun has set. The sky is dark. At approximately 1900 UTC, Apophis rises above the horizon. Not as a streak, not as a blur. As a bright point of light. Magnitude 3. Visible to the naked eye even from light-polluted cities. Brighter than most stars, moving visibly against the background. In real time, you can watch it drift across the sky. No telescope needed. By 2000 UTC, it's approaching its closest point. Tension peaks. Not that you can feel it. There's no sound, no wind, no warning sirens. Just a silent rock the size of a mountain, traveling 7.4 kilometers per second, passing closer to you than the satellites that carry your phone signal. At its closest approach, 31,000 kilometers above the Atlantic, Apophis will be moving so fast that it crosses the entire sky in roughly 4 hours. 4 hours from horizon to horizon. During that window, Earth's gravity will yank on it. The asteroid's path will bend by roughly 28 degrees. That's not a gentle curve. That's a cosmic ricochet. And here's the hook that should terrify you. We will be watching. Every telescope on Earth, every radar dish, every satellite that can point its sensors upward, we will be tracking it millisecond by millisecond. Not because it's beautiful, because we need to know exactly where it goes. We need to know if it passed through the keyhole. If it misses the keyhole and current data says it will, we get another pass in 2036, but at a safe distance. But if something shifts it, if the Yarkovsky effect was stronger than modeled, if a piece broke off and altered the mass distribution, if any variable we haven't accounted for nudges it sideways by just 600 meters during that Atlantic crossing, then the 2036 return isn't a flyby. It's an appointment. Okay, let's go there. Let's say the worst happens. Let's say Apophis threads the keyhole in 2029. Let's say the gravitational slingshot works exactly as the doomsday models predict. What does April 13th, 2036 actually look like? First, the math. If Apophis is redirected by the 2029 keyhole, the 2036 impact trajectory becomes a statistical certainty, not a possibility. A clock. We would know years in advance. By 2030, 2031 at the latest, astronomers would confirm the new orbit. And then the world would have 5 years to prepare for the inevitable. 5 years sounds like a long time. It's not, because here's the brutal truth about asteroid defense. We can't just nuke it. That's a movie myth. If you detonate a nuclear weapon near a rubble pile asteroid, you don't destroy it. You turn a rifle into a shotgun. You create hundreds of radioactive fragments, all still heading for Earth, now spread across a wider impact zone. The real strategy? Kinetic impact. Hit it early. Hit it hard. Nudge it off course by millimeters per second when it's still far away. That's what DART proved in 2022. We can move an asteroid, but DART hit a target 160 meters wide. Apophis is twice that size. And DART changed the orbit by 32 minutes. We would need years of lead time to build a mission, launch it, and deliver enough kinetic energy to matter. If we only have 5 years, if Apophis surprises us, we're not moving it. We're evacuating, or we're dying. So what does Impact Day look like? If Apophis hits land, say in Europe, Asia, or North America, it excavates a crater roughly 5 kilometers wide. The fireball extends 20 kilometers in every direction. Everything within 100 kilometers is flattened by the shockwave. The ejecta, millions of tons of rock thrown into the atmosphere, blocks sunlight. Global temperatures drop by 1 to 2 degrees Celsius. That doesn't sound like much. But 1 degree is the difference between a growing season and a famine. If it hits water, and statistically 70% of Earth is water, it's arguably worse. A tsunami hundreds of meters high radiates outward. Coastal cities vanish. The salt spray and water vapor alter atmospheric chemistry. The damage is less localized but more widespread. And if it hits during a geopolitical flashpoint, if nations are already stressed, already hungry, already armed, an impact doesn't just destroy infrastructure, it detonates civilization. This is why the 2029 flyby matters. It's not just a show, it's a test run for the universe's aiming system. So what are we doing about it, besides watching? In 2022, NASA's DART mission slammed a refrigerator-sized spacecraft into Dimorphos, a small asteroid moonlet. It worked. The impact changed Dimorphos' orbital period. Humanity proved it could move a space rock. Cue the celebration. But here's the context nobody mentions at the party. Dimorphos was 160 meters wide. Apophis is 340 meters. Dimorphos was 11 million kilometers away when DART hit it. Apophis will be 31,000 kilometers away in 2029. DART changed Dimorphos' orbit by 32 minutes. To deflect Apophis meaningfully, we would need multiple DART-level impacts, years in advance, with perfect targeting. We currently have 0 spacecraft capable of intercepting Apophis before 2029. 0. The next planetary defense mission, NEO Surveyor, won't launch until 2028. It's a space telescope designed to find threats, not stop them. The European Space Agency's HERA mission, launching in 2024, will study the DART impact site. It's a reconnaissance mission, not a weapon. So if Apophis surprises us, if the 2029 flyby reveals a keyhole trajectory we didn't predict, we have no hammer. We have eyes, we have radar. We have very smart people with very detailed PowerPoints. But we do not have a spacecraft on the launch pad ready to push a mountain out of the way. And that gap between detection and defense, that's where the real danger lives, not in the asteroid itself, in our readiness. The dinosaurs didn't have a space program. They looked up, they saw the flash, and 75% of life on Earth died. We have telescopes, we have models, we have warning. But warning without capability is just anxiety with a budget. Here's a question that should make you uncomfortable. If we discovered today that Apophis was locked into a 2036 impact, who decides what happens next? There is no global asteroid defense agency. There is no red phone. There is no protocol for telling 8 billion people they have 5 years to live. The United Nations has a space mission planning advisory group. They meet, they discuss, they recommend. But they have no authority. No military, no spacecraft. NASA would know first. Maybe ESA. Maybe a backyard astronomer in Chile who spots an anomaly and posts it online before the government can draft a press release. Imagine that headline, Asteroid confirmed for 2036 impact. Posted on Reddit, shared on TikTok, debated on cable news, denied by politicians, panic in markets, refugee crises before the rock even gets close. Because here's the psychological trap. Humans are terrible at long-term threats. We evolved to run from lions, not to plan for decade-away asteroids. Tell someone they might die in 5 years from a space rock, and they'll change the channel. Tell them they might die in 5 minutes, and they'll run. Apophis exploits this flaw. It moves slowly. It announces itself politely, years in advance. It gives us time to forget, to dismiss, to argue about whether the money should go to healthcare or climate or tax cuts instead of some rock that probably won't hit us. But probability is a cruel god. A 99% chance of survival sounds great until you're the 1%. And with 8 billion people, 1% is 80 million lives. That's not statistics, that's a genocide delivered by physics. Let's be honest about why you're still watching. It's not just the science, it's the stakes. Apophis is the perfect viral threat because it checks every box of human terror. It's ancient, named after a god of chaos from 5,000 years ago. It connects our modern anxiety to mythic dread. It's specific. April 13th, 2029. Not sometime in the future. A date. A day you might have plans. A day you might be at work, on a date, asleep. A day when the sky will change. It's visible. Unlike climate change or pandemic risk, you can literally look up and see Apophis coming. It turns abstract fear into concrete spectacle. And it's binary. It either hits or it doesn't. There's no negotiation, no policy debate, no gradual decline, just math, distance, and velocity. This is why Apophis dominates headlines every time it passes close to a telescope. It's not just an asteroid, it's a mirror. It reflects our fragility back at us. We live on a wet rock protected by a thin atmosphere, circling a star in a cosmic shooting gallery, and we pretend we're safe because the last big impact was 66 million years ago. But the universe doesn't care about our schedules. The Tunguska event in 1908 flattened 2,000 square kilometers of Siberian forest. The Chelyabinsk meteor in 2013 injured 1,600 people and blew out windows across a city. Those were tiny rocks. Apophis is a mountain. We're not due for an impact. We're overdue for the conversation about what we do when one shows up. Let's pivot to hope. Because 2029 isn't just a threat. It's an opportunity, a once-in-a-lifetime chance to study an asteroid up close without leaving Earth orbit. When Apophis passes, it will be close enough for radar mapping. We'll know its shape within meters. We'll know its spin. We'll know if it's solid or a rubble pile. We'll measure the Yarkovsky effect in real time. We'll watch how Earth's gravity affects it. We'll learn more in those 4 hours than we've learned from 2 decades of distant observation. This data is gold for planetary defense. If we can map Apophis precisely in 2029, we can refine every model for the next century. We'll know if the keyhole is truly closed or if there are others we haven't seen. We'll know if a future mission could land on it, study it, or redirect it. Some scientists even want to send a probe to meet it, a rendezvous mission, catch Apophis during the flyby, hitch a ride, study it up close. It's audacious, it's expensive, and it might be the smartest insurance policy we could buy. Because here's the final hook. Even if Apophis misses in 2029 and 2036, its orbit will keep bringing it back. 2068, 2116. Each pass is another roll of the dice. Each pass is another chance for a gravitational nudge, a collision with another rock, a solar flare, a piece of debris, any cosmic wildcard, to shift its path. Apophis isn't going away. It's our neighbor now. And neighbors can be friendly for decades before they knock down your door. Let me tell you something that should keep you up more than Apophis itself. As of 2024, astronomers estimate we've found roughly 40% of the near-Earth asteroids larger than 140 meters. 40%. That means 60% of civilization-ending rocks are still out there, in the dark, unmapped, unmonitored. We only found Apophis because it happened to cross a telescope's field of view. If Kitt Peak had been cloudy that night in 2004, we might not have seen it until 2014. Or 2024, or never. The Chelyabinsk meteor, we didn't see it coming. It came from the direction of the sun, hidden in the glare. It entered the atmosphere, exploded, and injured 1,600 people before anyone knew it existed. Apophis is the devil we know. But what about the devil we don't? NASA's NEO Surveyor telescope, launching in 2028, is designed to find 90% of these threats. But it's already delayed, underfunded, competing for budget against Mars missions and lunar bases. And, even when it launches, it will take years to complete the survey. So the real question isn't, will Apophis hit us? The real question is, how many Apophyses are still hiding? And the answer is, probably dozens, maybe hundreds. We're playing cosmic roulette with a half-loaded gun, and we're arguing about whether to buy more bullets or more bandages. I want you to think about your age right now. However old you are, add 5 years. That's 2030. Add 10. That's 2035. If you're under 40, you will almost certainly be alive for the 2029 flyby. You will be alive for the 2036 window. You might be alive for 2068. This isn't abstract future history. This is your lifetime, your sky, your planet. And on April 13th, 2029, you will have a choice. You can go inside, close the blinds, scroll your phone, pretend it's just another Friday. Or you can step outside, look up, find that point of light moving fast above the horizon, and understand that you are watching a mountain pass closer to your head than the satellites that run your world. That moment will change something in you. Because once you've seen an asteroid with your naked eye, once you've watched a potential killer glide past like a silent train, you can't unsee it. You can't unknow how thin the margin is, how quiet the universe is, how little it cares about your plans. Apophis won't hit us in 2029. The math says so. But math is just a photograph of a moving object. It captures a moment. It doesn't capture the next moment or the one after that. So here's the update. The 2029 update. Apophis is coming back. It's not a theory. It's not a maybe. It's orbital fact. On April 13th, 2029, it will pass closer than our satellites. It will bend under our gravity. It will test our readiness. And then it will recede into the dark, looping back toward the outer solar system, carrying with it the secret of whether it will ever return angry. We've ruled out the impacts. For now. But ruling out an impact is not the same as mastering the threat. We are still a species with one planet, no backup, and a telescope network that misses 60% of the killers. The countdown to 2029 is already running. Every day, Apophis travels another 2.5 million kilometers along its path. Every day, the Yarkovsky effect whispers against its surface. Every day, we get a little closer to a Friday night in April when the sky will remind us who we really are. Not masters of the cosmos, not conquerors of space, just passengers on a rock, looking up, hoping the math holds, knowing that one day it might not. Mark your calendar. April 13th, 2029. Friday the 13th. The night the god of chaos passes close enough to touch our shadow. You'll want to be outside for this one, because if the universe ever decides to send us a warning shot, it won't come with a siren. It will come as a silent point of light. Moving fast, getting closer, reminding us that in the grand scale of things, we're not the main character. We're just the audience. And the show is about to start.